Hey everyone, and welcome back to coding. Today we are learning the second part of ACSL's computer number systems. Today we are gonna continue and learn how to convert from decimal. Unlike last class where we learned how to convert to decimal. So the website says the algorithm to convert a number from an arbitrary base requires finding how many times successive powers of the base go into the number, starting with the largest power of the base less than the starting number. For example, converting 3,306 from base 10 to octal proceeds as possible. So the largest power of 8, that is less than or equal to 3,306, is 512, which is 8 to the power 3. So then you divide it by that, and you'll get 6 times that. So then you get this number. So the next power of 8 is 64 times 8 to the power 2. Or 64 is 8 to the power 2, and you divide that by 64, which you'll get 42, and the next power is 8, and you divide it by 8, and then 2, you divide by 1, so that's 2, and the answer will be, you put them all together, so that's 6352 in octal. So, let's have an example. So, for example, if you are 106 from octal to decimal, then as the problem says, it says you find the largest power of 8. So I think the largest power of 8 is 62 or 64, which is 8 to the power of 2. So that's 106 equals. So how many of those can we have? So that's, 1. So that's 1 times 64. And then plus, so that's 104 to 04 or 6 minus 64, and you'll get 42. So that's plus 42, and then the smallest is 1/8. So that's 42 equals, or how many 8s can go into 42, and that is 5. So that's 5 times 8 to the power 1, and that's plus 2. And then 2 equals, so that's 8 to the power 0, so that's 2 times 8 to the power 0. And you put them all together, so that's 152 in octal. And you have your answer. Or 152 in decimal, so that's 152. Moving on to converting between binary, octal, and hexadecimal. So to convert from octal to binary, you replace each octal digit by its corresponding 3 binary bits. So for example, you convert each digit here, so that's 3 is 0, 1, 1, 7 is 1, 1, 1, 5 is 101, and you just put those together. So you have to make sure that they are all 3 digits. It is very useful to have a table like this around so that you can have it for reference. Um, it is very convenient to have in the competition. So as you see, you convert the 3 digits. Sometimes it's 4, 5, and to their 3-digit binary and put them together. So let's have an example. For example, we want to convert 365 in octal to binary. So 3, you find the individual binary numbers. So 3, when you look on here, 3 in binary is 1, 1. So to make it a 3-digit, you add a 0 to the end. So that's 0, 1, 1. And 6 will be 110 or 110. And 5 will be 101. And that will be that. So then you put them together. So the answer is 0, 1, 1, 1, 1, 0, 1, 0, 1 in binary. And then the binary, you just write it down, and that's the answer. So that is very simple and very easy to do. So next we have converting from hex to binary. So converting from hex to binary is also really easy. So you just replace each hex digit by its corresponding 4-digit bits this time. So in this example is FD in hexadecimal to this binary. So F is 1111. So F is 15, and its corresponding binary is 1111, and D is 1101. So then you just add them together and you'll get the binary. So we can have a quick example here. We can have 5, 2, 3 in hexadecimal, 2 decimal, or 2 binary. And like the problem says, you take each of them's binary. So 5 would be 101, but it's 4 binary digits, so you add a 0 to the end, and 2 is 10, so then you add 2 zeros onto the end, and 3 is 1, 1, so you add 2 zeros, and that is your answer. And converting binary to hex or octal is you group the bits by 3s or 4 and convert them to each. So as you see here, if you're converting it to 8s, you start from the end and group them by 3s and just convert them. So that's 10 in binary is 2 in octal, 0 is 0, 1 is 1, 111 is 7, 0 is 0, 101 is 5, and 100 is 4. So it's the same thing with hex. It's just you group it into 4s and then convert it. So it's just remember to start from the end when you are grouping. So let's have an example. For example, we can have 1101 11001 to let's convert it both to octal and hex. So to convert to octal, you want to split it in threes, so which is easy, and then turn those into the numbers. So 110 110 is 6 in octal. That's 6. 111 is 7 in octal. And 001 is 1 in octal. And it is actually the same in hex. So in hex, that's 110, 111, 001. You just split it into fours. That's 4, 4, and then that you can add 3 zeros at the end. So that's 1. 1011 1011 is B, and 1001 1001 is 9. So the answer in hex is 1B9, and octal is 671. So that's it for computer number systems, and another feature of hexadecimals is lots of systems use it to represent different colors, as it is it can get to really large and very specific. So 0 in hexadecimal is black, and white is the highest, which is F, 17. And the hashtag is to show that it is a hexadecimal, as in colors. So on the ACSL.org, you can go to the study materials to find the junior division and computer number systems, to find some resources on these. So this is a binary tutorial, and you can also find some more information on that, some sample problems, and some video resources. So thank you for watching this video. Make sure to check out the resources and do some of the problems, and we'll see you next video.